Today, let me teach you how to write a simple program to insert a node in a linked list. To start with, since we are going to allocate memory dynamically as and when we want to insert a data into our linked list, we need a special header file called stdlib.h which takes care of allocating memory. So let me include that header file. Yes. So before we start, as you all know, uh, every node in linked list will have two parts in it. One part is the data part and other is a pointer to the next data, which will hold the address of the next data. So let's declare a structure which is used to allocate memory for dissimilar data types. Struct, let me give the structure name as node, and the members of the structure is, one is an integer, let me name the member as data part, and the second part will hold the address of a similar structure. So similar structure struct node. So let me have the name of the second part of the structure as next. So this is how we declare a structure with two parts, where one is the data part, other is a pointer to a structure. So this concept of a pointer pointing to the same structure is called self-referential structure. I need two pointers for the structure. One is to always point to the first node, and second pointer to traverse along the list. So let me have two pointer to a structure. One is called head, other is called temp. Okay. Now coming to the main function. So I just want to just use three functions. One is to create a node, create node function. Then second one is to insert in the beginning. And third is to display the contents of the linked list. So our main program, simply a call with three simple functions. So let us define a function called create node first. Create node. Since I'm going to define a function create node. Now here I'm going to make use of the pointers that I've declared in the structure. So whenever you want to allocate memory for a node, we have to use a function called malloc. It's a function which can allocate memory to any size of data. Since I want to allocate memory for the node, I'm going to give malloc size of the operator, which returns the size of the memory what we give as a parameter, size of struct node. So this line allocates memory for a node with two parts as I've declared above. So this function will return an address of the memory. So I have to store in a pointer variable. Let me give it as head. So head will store the address of the first node that I have allocated for memory. Now let me declare the next part as null, because this is the initial node what I have created. So this is how you create a node for a linked list. So once you create, you have to return the address of the newly created node to the main function. So let me have the return type as a pointer to return head, which will have memory for the data and the next part. The next part is null. So I am going to give the return type as a pointer to a structure. So let me also declare this function before the main. We're returning a pointer structure where I'm not going to pass anything. So let me give it as void. So one function is over where you're creating a node. Okay. Now next is inserting in the beginning. So inserting the beginning, so I'm not going to turn anything. So void function name is insert beginning. Now when I want to insert it, already I have an empty node with head part in it. So again I have to allocate memory and store the address in a pointer variable called temp. So again malloc, so I can just simply copy it. So this allocates memory for a newly created node and the address is stored in temp. Let me store the data what I wish to store in the first node as 10. So temp data equal 10 will assign the value 10 to the data part of the newly created node. Now I can have the next field as null for now. Now this is a newly created node. So you have to see that head always point to the first node. Since this is the first node that you have inserted data, I want the head pointer to point to the newly created node. So head address of temp will come to head. So head is equal to temp will assign the address of the newly created node to the pointer called head. So both head and temp will point to the first node in a linked list. So this is how you insert the data in the beginning of a node. Good. Now let's again declare this function. So I'm not going to pass anything. Yes. Now coming to display function. So I'm not going to turn anything. Function name is display. Now head as well as temp points to the first data. Suppose you want to insert more data, so always the head will be pointed to the newly created node. So let me have the head node, because when I want to print the data, I always have to start printing from the first node. So always head will have the data of the first node. So I am allocating the address of head to temp. While temp not equal to null. So you can perform two operations. One is to print the data. Since the integer, the format specifier given is, so if you want, we can give to show it looks like a linked list. So where's the data stored in the structure of the node? Temp data. And after printing the data, I have to traverse the temp pointer to the next node. So temp equal to temp next will put the address of the next node to temp, so that I can print the second data when the while loop goes for the next time. So I have to declare the function display. So this is all about creating a node in a linked list where you allocate memory for a node and return the address of the newly created node. Whenever you want to insert the data, you can call the function called insert, and every time you allocate a memory, you store the address in a temp pointer variable and put the data in that part and make the next part is null, so that you can, when you want to traverse the data, you can print the data until your data is null. So let me run the program and see. So we have an error. Let me check it. Temp next equal to null. This is a small spelling mistake here. So let's run it. Yes, we got the data as 10. Because I have given only one data. So we have the linked list data as displayed as shown in the program. Thank you.